Cool. All right. Yeah, welcome to the second webinar. Thank you all for joining. Today we also have Isabel, I believe, joining, who helped out with the course. So hi, Isabel.
Yes, I'm here. I will join with my video soon.
No problem. Cool. Um, yeah, so I guess we'll carry through. Last time, I believe we covered modules 1, 2, and 3 and just went through some of the assignments. So we will probably just do a similar webinar to last time. It may be a bit shorter just based on the number of assignments we've had now as opposed to the beginning, but there's plenty of time for questions and discussion as well throughout. So if you have any questions throughout the webinar, just feel free to open up. There's only a few of us in here. Cool. So this is where we are. We've currently in module 5. So we've done module 4 where we had all these sort of more practical examples and spoke to people in the industry of what's actually happening and how to implement circularity. And then module 5 was a bit more technical, where we spoke about the LCA, and then you had the chance to do the material flow analysis. Yeah, so we also have a small example website that Bernadette will present, which is quite useful. Cool. So yeah, here's the quick recap of module 4, where we're at Gar Maritime, GTB Lab, and the Natural Pavilion, and sort of discussed how they had implemented circularity through their projects. And then in the assignment at the end of the module, we got your submissions for analyzing a certain material in your facade and the certain flows and things associated with that material. This here was the assignment. So I think to begin, we will go to the sketch drive and just kind of have a look at our comments that we had for each of the submissions here. See if this is working. You can all see my screen fine, I assume.
Yes.
Cool. Cool. So first up, we had, I hope I'm pronouncing it right, it's Trinity. I think, are you here again this time? I thought I saw your name, but either way, we had this project where it looks like a lot of the knowledge has been taken from our module on glass, where we spoke to Martin Teisch and things like that. So it's really interesting. It's good to see that it's being applied here. Um, what I guess no direct comments. We thought this was a pretty well done assignment. But I guess just what we could add is some more information that you might find interesting. Um, so for separating the IGUs, a project that you might find interesting is this IG2 pieces, which is, I believe, the first piece of equipment that can separate IGUs in a automated way. So this would definitely be interesting for what you've proposed in yours with the reuse strategy. So hopefully you can see this video of how this works. And yeah, it's just a more automated process for separating the glass, and then you either have the complete panel for the reuse strategy as you suggested, or it will also make it much easier to recycle by separating the materials. Um, cool. But yeah, overall, I think it was quite a good assignment. It was really interesting. It was really nice to see that the what we had wanted to come across in that module with where we spoke specifically about glass had come across. So yeah, I think it was quite a good assignment. I see you're now here, Shrindi. Did you have any comments on your assignment?
Sorry, my internet cut out and I just
No,
came
that's
back
okay.
in. Um, uh, no, I guess I thought my stakeholder diagram was a bit messy, but I was just trying to fit in what I could.
Yeah, so it's not, we didn't really, it's kind of hard to fit it in the space. I understand. I had the same problem when I did the example. But no, I think it comes across quite clear. It's very similar to the example, and yeah, I think it's quite clear. I don't know if you were just in for the call then, but we just as a suggestion, which is maybe interesting for you, we just showed this certain project here or this piece of equipment that's been developed. the IG2 pieces, and it is able to separate IGUs in sort of automated way,
Yeah.
which is probably more interesting for your project. And when you move on to the last assignment, things like that, it's researching these sorts of methods is maybe of interest to you.
Yeah, no, absolutely. And I think I mentioned last time I heard something about this from like Lisa Remming as well. And I'm very excited about it. Actually I did have a question. I was wondering if uh TPS spacers are becoming more popular. So like kind of like a composite chemical spacer as opposed to like the aluminum or stainless steel spacer with the desiccant, with the PIB, with the silicone. So it's just many more components in a traditional IGU. And at least a company near me, and from what I'm seeing, um, they're called TPS spacers, where it's like I mean it's still a polymer, but it does the chemical bonding, and the desiccant is incorporated in this material. And I'm wondering if one material is somehow better.
Interesting.
Um, well, maybe it's not one
Um,
material then.
Perhaps, Isabel, are you aware of this certain spacer? This is the first time I've heard of a TPS spacer.
Actually, me too. So I'm probably it's country specific. So maybe if you heard of it in the US, maybe there are some companies who actually try to get an approval for it and want to get it into the market. If you say it could be of interest and you have projects and you find that the uh, sustainability aspect may be of advantage here, of course, that could be of interest. I'm actually not sure if I've heard of it in Germany. So maybe it would be interesting which company actually produced it is, where it came from.
Yeah,
Anyway,
sorry, go ahead.
no. I just wanted to add that in the end, you always have to question, oh, what is your requirement? So how much load does your facade has to take? Is that
Mhm.
a space of interest that could provide you with the requirements? And if it is, and if the ecological aspects maybe of interest, then this could be something which will come more and more. In the end, it's often also a political issue, and companies always want to sell their products. So always try to critically question whether, even if they say it's ecologically better than other products, really question whether that's the case for a specific project you are working with. So do you have a specific project where you're thinking of using those TPS spaces?
No, it's a company called Virocon near me. They call it something else. They call it VTS, but it's the same thing. I watched them apply it. It was really quite incredible. It was automatically applied, and it was immediately chemically bonded to the glass. So much so that they were lifting the glass with the face of the glass. All of us engineers were aghast. But anyway, we talked more about them. Apparently, it's supposed to have very good thermal properties. The only reason I thought they weren't claiming it to be green, they were just claiming it to be extremely efficient. And the fact that it does, 4 or 5 um, materials work at one time. And I know people are working on recycling silicone. And if this is essentially a plastic, I was thinking maybe it could be recycled too. And also because it's a chemical bond, I was wondering if the same company that developed it could develop some way to like release that more easily at the end of life. I don't really know if these things are possible. It's just something I was thinking about. Instead of separating several materials, if we could work with one, even that's an advantage, even if we do have to cut it out.
Definitely. I actually just remembered that maybe I have actually seen such a thing on Glass Tech a couple of years ago from the big Finnish company Glaston. And I just
Mm.
Googled it. They actually really use, or maybe even this TPS is one of their uh, specific names for that kind of spaces. And they are quite into the sustainability issue and want to include it in their solution. So I think they will probably also think of exactly the things you just mentioned, like trying to think this during the development as well, so that they try to recycle it or try to make something else out of it. But I'm not that deep into the chemical reactions of such thermoplastic spaces, and would have to ask them. But actually, I will be on a conference next week, which they organize, so I could actually ask, and we could give you a comment on that afterwards.
That would be really lovely. That'd be very exciting.
Cool. Great. Other than that, I think, yeah, this assignment was sort of exactly what we imagined we would get in the results. It's good to see that it's come across quite well. Did you have any other questions or comments?
No, I don't want to dominate. Let's keep going.
No, that's fine. We'll continue on. The next one was from Partridge, who I don't think was here last time. Are you here, Partridge? Either way, maybe you're listening to the recording. This one was in Namibia, where she had mentioned oil drums being reused on this certain project and sort of rolled out into roofing material, which I thought was pretty interesting. Yeah, it's definitely not something I've seen. It's quite cool to see that it's actually on a project, I guess, as well, and just an interesting thing. I saw your comment as well about, I was a little bit confused about the scaffolding. Open this up. Yeah, there was talks about reusing this for scaffolding, which I found a little bit unclear. So maybe you could just edit in the comments to clarify what this means. But the major comment we had was just to go through again the R strategies as we have them in the module. Often you'll see the R strategies, I guess, in different forms. Like there may be different numbering systems, or there might only be 6. It can vary, but at the core, it's having this hierarchy is probably the most important point. So having refuse at the top and waste at the bottom, and then everything between. So yeah, I think Patrick, just go through and check where you've used your R strategies, and I guess just check the numbering, see if it feels applicable. Is that sort of the same comments you would have, Bernadette?
Yeah. And also, can you just go a little bit up?
Mhm.
I also just wanted to say it's very interesting to use yeah, an oil drum for a roof. I was just thinking about this is now has nothing to do with the circularity aspect, but more with the acoustics. I was a little bit involved with a building project in Uganda, where we also had metal roofs, and there the big problem was the sound of the rain that kind of like drops on the raindrops that drop on the metal roof, and then it's just very loud. It's just maybe a tiny thing that I remembered of that project, but I think it's very interesting to see a product that was used in a totally different way to get a new life. And I think, Nathan, didn't you also research a little bit about the project in a different
Yeah,
tab?
we opened the project up and had a
Oh,
bit of
yeah.
a look. It's quite cool. You can see the photos here of, so the roof is, by the looks of it, just used externally. And here, I hope you can see, yeah, you can see on the right is these oil drums. It's just a pretty interesting project, I think. Overall, there was a lot of recycled materials throughout the project. They have this kind of like earth ship techniques of ramming earth in old tires. You can
Tires.
see
Yeah.
here. Yeah, and this website here, Namibia Archaeology of the Future blog, has quite a bit of info on this building, and it's quite an interesting project. I think it's maybe 20 years old now, so it's cool to see that this line of action was happening back then. But yeah, cool project. On your comment about the acoustics, that's, for me, coming from Australia, it's most of the tin roofs are quite common, the metal roofs. And so for me, it's like it's quite nice. It helps me sleep actually having the rain on a tin roof.
It depends on the use of the room underneath. So what we planned there was a school room, and then if it's raining, it was just too loud.
Yeah.
And then it's possible to plan it and then have like little spacers to disconnect it, and then it's a bit less loud. But still, it's just, yeah, one thing that you need to think about where you reuse your things and if yeah, it's the right function.
Yeah.
But yeah,
Cool.
I like the colors, so it's nice.
Cool. And did anyone have any questions about this project before we continue on?
Yeah, I think the comment that I'd left was mostly about like the way the R strategies are laid out in the life cycle. It's very linear. It's like this happens and then this happens and then this. When I had imagined the R strategies to be several parallel strategies that could be used for the same material.
Yeah.
I don't know if I was just nitpicking or if that's actually how we're supposed to understand it.
You mean in figure 2 here?
Uh-huh.
Yeah. Yeah, if I'm quite honest on my screen, I found it, I was reading this one today and I found it quite hard to read the writing on this screen.
Oh, that's fair.
But yeah, I saw your comment as well just before here. Let's see. Yeah, I think I just had more of an issue reading what's happening, but I think this circle here seemed to make sense to me because it's the drum being within this circle. I think what Partridge had just tried to explain is this sort of production of the drum has already
Mm.
happened, but then here the circle is able to close by reusing the drum or remanufacturing, repurposing it in different ways.
Yeah.
But I think what has been shown is that the metal is still being reused within this loop or repurposed, but before the production, it was still mined and produced as a metal drum. Because the metal drum isn't from a recycled source, I think is what is trying to be said here.
Yeah, I think they made it additionally challenging for themselves because they picked something that was already being used, like a very unusual item as opposed to like aluminum or glass or something that's more traditional. So
Yeah, yeah.
yeah. No, but it was super
Yeah,
interesting.
it is quite cool, yeah. But yeah, you're right, it's tricky because it's not a building material, so
Mhm.
it's a bit of a different case. And
But just to jump into the discussion, one thing about the R strategies. So, like Nathan said, try to always go through the ladder, the triangle of R strategies. Nathan, can you just open it once again?
this one?
Not this one.
Oh, sorry,
3.2. Yes, this one. And then go through and think, can you refuse it? Can you rethink it, reduce, and then go each step down? And for example, how Pedrich could make it a bit simpler is just to say you reuse it and then not even use a remanufacturing part, because I also had some question marks when I read that, because I was thinking, okay, you reuse it and then you remanufacture it again. It's kind of like doing too much if you can just use one. So if I would have done that, I would just say I'm going to reuse it. And then, of course, if you need to remanufacture it, then you're not just reusing it, then you're remanufacturing it. And then you're going down the ladder of the R strategies. And then if you jump back, Nathan, to the assignment. Yeah, here. I have it open on different screens, so please apologize if I don't see like I'm looking into the camera. So what we have here is it's a lot of R's just circling around, and to be honest, it's a bit too much of R's. I also want to leave a comment to address that and maybe even leave a better way to draw that, because it's a nice thing that you just reuse the material in its whole, but the thing is you're not reusing the drum in its own. You need to cut it up and then do something with it and then use it as a roof. So it's quite a bit tricky to get it into the sketch, but yeah, just my 2 cents about the topic.
Yeah, that makes sense. All right. Continuing on to the next one.
Mhm.
This one's from Amir, I hope I'm pronouncing that correctly. This one here was a little bit more confusing with the life cycle material. I think maybe hasn't addressed specifically the material itself of what's happening with the aluminium through the process. But what was good about this is that the detail is here, and you can see how this is sort of mechanically fixed, similar. I guess last time we were talking a bit about Durnell's project with the stick system and how that would come apart. And I think it's quite similar of how this one would be disassembled, where it's all screwed from the top here. Something about the other submission. I don't know. Are you here, Amir? No, maybe listening. That's okay. But something about the other submission is I'm not 100% sure if you've taken these details from this project. For me, it looks like these two details may be from different projects, which is okay, but maybe it's just good to understand how these details are going together. So I couldn't find many details on the actual project itself, but it's probably important to note that with these details shown here, they can be disassembled, and so it obviously makes it much easier to be recycled. But something with the freeform projects, in my opinion, is that actually reusing the nodes is quite difficult because they are a bespoke design. So every node has its own geometry. So the only way you can realistically reuse this is to make the same geometry again. So I think it's great that these are disassembled in a certain way, but it should be pointed out that they can't exactly be reused. The structural members could be reused, but a lot of the nodes, in my opinion, are quite bespoke, so reusing them's quite difficult. Would you agree with that sort of notion, Bernadette? Or
Yes. So yes, you can rebuild the building in a different location, and not easily, but it's possible. But yeah, you need to be careful with using the term reuse. So yes, if your goal is to rebuild the same structure in place B, then yes. But otherwise, it's hard to reuse something that specific. But it depends a little bit on how generic the node is. But yeah, there we need a bit more information, to be honest.
yeah. Yeah, I think it's probably important to note that I think, Isabel, you know quite a bit about these systems, but there are with the Miro system, for example, it can be quite standardized, but often it would be a bespoke solution, correct, with the nodes.
Correct. So for the Miro system, it's really a very standardized system, and typically you can really play around with geometries you can make from it. But nowadays it's not that usual anymore or I would say that most architects, also due to new manufacturing techniques, wouldn't use the Miro system, but other techniques, like also thinking of 3D printing or some more advanced welding technologies. And then you are correct that it's really geometry dependent. So yeah, this is specifically an aspect you have to think of. And if you already consider reuse cases in future life cases, that this may not be that easy. And also when it comes to actually what is it called? Yeah, if something breaks and you have to replace it and the things aren't there anymore, that could already mean that you will decide to maybe demolish a whole building and then put a new one because you can't use the technology, or you wouldn't like to use the technologies which were current technology at a specific time, that it's not really affordable or does make sense economically in the future. So if you think about systems which are very smart today that can be reused or repurposed in the future, that's also kind of a sustainable way of thinking, which is somehow a combination of rethink and then reuse or remanufacturing in the future. Yeah.
Cool. Thank you. Makes sense. Cool. All right. Yeah, I think that's the overall comment. Or oh wait, this one here, I think is maybe we will provide a comment and just sort of clarify how this life cycle of the material itself is happening, because at the moment it's just the R strategies, but it would be good to see sort of which material you've chosen in your assignment, whether it's the glass on top of the structure, it's the steel behind, and things like that. But cool. But anyway, thank you for the submission, if you're listening.
Maybe just another comment on the stakeholders. I find it also a little bit confusing that it's a very circular way of presenting it at the bottom.
Yes, I see it.
Really difficult. Yeah, it's really difficult to really read, but typically it's not that circular along a product chain.
Yeah, I think the other examples we saw are much clearer of what we're after, with the different interactions of stakeholders.
And
Yeah,
the
right.
dependencies, which actually will then, if you really have to think through such a project and really want to reuse things, this is where the key challenges arise due to the high dependencies and interconnectivities between stakeholders and the interest groups.
Yeah. Cool. But so far, that's the submissions we have for assignment 4. We'll provide some comments. I think this submission only come through, late last night. So we'll provide comments and see how things can be modified. But we don't want to be too critical because we're happy that people are submitting the assignments. Continuing on, I think, to the next module, which is the more technical module of life cycle assessment and material flow analysis. When we were doing this course, we were kind of discussing how much involvement of the life cycle assessment we have in the course. We chose not to go too in depth of the life cycle assessment because we simply don't have the time in this course to teach it to the, I guess, capacity we would like to teach it. Which is why we've chosen material flow analysis, as we hope it's a bit quicker and easier to understand and visualize, and a bit less heavy on the work. Would you say, Bernadette?
I absolutely agree. Yeah, we were discussing quite lively which assessment method we should teach. And yeah, we said in 6 weeks, maybe 6 weeks, just life cycle assessment would be good. But just 1 week for the assessment methods and then teaching material flow analysis and life cycle assessment, that was too much.
Yeah.
And it was more important for us that you understand 1 better than 2, kind of. So that was the thinking of our side from that part.
Yeah.
But
hopefully we've given a good overview for the life cycle assessment. And I think there's plenty of resources to continue learning if you wish outside of this course.
Yeah, we saw that there's 1 submission this night. We didn't have enough time to really get into that.
Yeah, should I open it, or do we want to do an example instead of yours?
Maybe the example would be a bit better. Yeah.
Okay, cool. Yes, this one here. So to the link.
Yeah. Yes, that would be perfect.
So Bernadette, we'll talk about this resource.
Yeah, so I was looking for a webinar for a good example, and I came across this one from the a website from the European Union. And what I wanted to talk about is, why do we need a material flow diagram and how can we use it? So you probably already listened to the interviews with Magda and me. And there we also talked in one about the difference of an ACA and an MFA. And the big difference is, with a material flow analysis, we really just understand, okay, from where is the material coming from, the input flow, and where is it going to? And then Nathan, now you need to tell me if you can see my scribbles, stuff like that.
Yes.
Okay, good. Are pretty interesting because then we understand how much percentage-wise is going back into our input loop and how much is going out. Going out doesn't mean necessarily that um, it's not possible to recycle or it's not reusable. It just means it's leaving our view system boundary, which is in our case, okay, in this case, something different, but in our case, a facade. So of course, parts of the facade or materials of the facade can be used to build something different. But what we want to understand in our case is how can we make our facade circle as circular as possible, and how many arrows can we flow back into our input stream. And maybe Nathan, if you click on this part. So what we saw before was just the total stream, and I'm not even sure if it's gigaton in a
Yep.
specific unit. Gigatons, yeah.
Yeah, and I think you can change the units as well in this.
Oh yeah. It's not so important, but yeah, it's possible to change. But before we saw, okay, how much is flowing out and how much is flowing in, and now we can really understand, okay, how much of the big flows that we have in the beginning flow out again or are flowing back in. And one thing that we're realizing is that we have much more potential to flow back than we foresaw, especially with the yellow material. I don't want to go too deep into this example because it's not a facade. It's more an example of how this could look like in your case and why we should need it. And then we can say how circular is our facade in total. Do we have 5% of material that flows back? Then we still have 95% of circularity potential probably to close the loop in its entirety. And the big difference to a life cycle assessment is the life cycle assessment, you need to do a big material study before to understand what happens with the material in each life stage. But the number that you're getting afterwards is the impact on the environment, not a number for your circularity. It just says, okay, this much CO2 equivalent is emitted into our atmosphere afterwards, or this much energy is used at the beginning in the A phase, or we can get back in the D phase, but it's not really saying something about the circularity aspect. So if we want to say something about the sustainability of a product or of a facade, we need to use both assessment methods. But if we really just want to say something about the circularity potential or the circularity in its total, we need to use a material flow analysis. And like I said, it's a analysis to understand how much material flows into our product and how much flows out in the end of life stages. And here it starts to get a bit tricky, especially if we're talking about the system definition. So for example, if you say you have a single layer brick wall that consists of brick and mortar, you maybe think this is already a good definition, a good system boundary, but this can mean so much. It can mean, okay, you're just looking at 1 square meter or you're looking at 100 square meters. So you kind of need to be very precise on what you're looking at, and also say maybe also how many years this wall is standing, because maybe after 50 years, if you're looking at 100 years, the facade needs to have an update of the mortar, for example, because the mortar is getting a bit uh, is is not working anymore, and then we don't have the function of the facade anymore. And then we have a new loop of materials coming in, coming out. So we need to be very, very specific at the very first step, the scope and objective part of our material flow. And then the second part, or the second step, the data part, is of course a bit hard because we need to understand, okay, what material is in our facade, and if we use our brick and mortar facade, of course we have just our brick and our mortar. but maybe we have a mortar in front of our as our surface finish that we need to address. And this is something that we can add into our boundaries in the beginning or leave out. And a lot of the time, you're going to notice things maybe in step 2, step 3, step 4, that you can circle back and I don't want to say redo, but refine your material flow analysis. And this is also a similar work progress with an ACA. It's you're going through circles again and again until you get the final realistic analysis that you want in the end. And this is totally normal. It's just a thing that sometimes we teachers need to warn our learners for, because it can feel a bit frustrating at the beginning if you have never done that before, but that's a totally normal process to go through. So you're realizing in step 2, oh, I forgot about the mortar. Just go back to the scope and objective, add it or leave it out. Depends on what you're after. What is your objective? What do you want to look at? If it's your entire facade, then you need to add it. And then you go back and add the material in your step 2 data. And then it gets interesting, because in the process, as step 3 in the process and in the data part, the big question is, where do you get your data from? And here it's quite tricky to get data, because normally you want to show your facade, the realistic facade that you're having in front of you, but you have no idea what happens in the future. And this is where, if we're then going into the in my part, in the sciencey part of that, you're starting to look into different scenario development. What happens in 50 years? Is it maybe possible to recycle it a bit more? And then you have different scenarios in terms of recyclability that you can look into. So what helps me if I just want to have a simple material flow analysis, I look into what is possible now. So for example, can I recycle glass to 100%? If yes, I research that, find maybe a manufacturer or a paper that says it's possible, or it's possible to 95%. Then I know, okay, 95% of my mass can go back, but 5% is going to be waste because of breakage or the delivery. It's just not possible at the moment. And then I kind of piece together through literature and research, or maybe even talks with people who build or recycle those elements, to piece together my material flow analysis. So I wouldn't say the hard thing is to draw the Sankey diagram. The hard part is to get the information bits together and don't lose the overview over all of the information bits that you gathered. But this is also something that can make a lot of fun, because while you're researching, you're understanding the whole process and the whole material so much more, and you understand it in a much deeper level. And then when you go on and really look into different facade designs, you understand, okay, what are the points that you need to be careful about? For example, oh, it's easy to manufacture it, but as soon as we start to, for example, disassemble a brick and mortar wall, a lot of the time, the bricks break because the mortar is too strong. Maybe in the beginning, we need to find a better solution for the mortar, that it's better to break it up, or we find a better solution to use the broken bricks. Then we are starting to talk about the solutions, but it's always good to find the, I want to say, scary bits of our material flow analysis to understand where do we need a solution. And then it's a fun task to find a solution for. And I think in my whole monologue right now about material flow analysis, the biggest point I want to come across is, don't be afraid. It's a lot of fun to understand your material. It's a lot of fun to understand the process. It takes some time, and the assessment is sometimes feels like a lot at the beginning, but as soon as you have your first material flow analysis, or maybe your second or your third, you're also learning so much more about the material and how a material or a product is being produced, or then recycled in the end. And this is so much fun.
And so
Any questions?
yeah, I was going to say while we're on the material flow analysis, does anyone have any direct questions with the assignment or any difficulties with the material flow analysis? Because this assignment is probably one of the, I wouldn't say tricky, but it's also like the one that has a more clearly defined answer for you. So maybe it's easier to clearly have a question also. Anyone?
I wish I'd gotten further. Actually, the part where I am is just kind of looking into what materials are even in bricks and like looking for EPDs. And the EPDs are mostly giving me answers in terms of environmental impacts. I was able to find several, but nothing that clearly says, okay, there's this much. The closest source I came to was Wikipedia. That was like there's, 30 to 40% of alumina or like I don't know, just like various amounts. So I was just wondering how important the like finding the perfect source was or what your expectations are.
I think, correct me if I'm wrong, Bernadette, but I would almost say it's okay to sort of go outside the scopes of the actual project. And if you find a good source that enables you to communicate what you want. So for example, obviously, if your building's in the US and it's brick, it's all these things, it's really hard to find a source with a limited amount of time. So if you do find a good source that maybe isn't in the region, but is outside the region, or it's more specifically bricks. For example, mine was aluminium use in the European Union. It wasn't a
Mm.
facade specific aluminium use, but it was just aluminium use in general, which is through all products. And for me, when I did the example assignment, it was easier to, with the limited amount of time, because you can't go and interview, you can't go talk to people, get more information. It was easier to find a good source and then kind of, as Bernadette said, like circle back and adjust my scope to what was sort of more suited, if that makes sense. Would you agree that for a shorter assignment, Bernadette, that's a more reasonable approach?
Um, of course, I want a lot of things, but I totally understand you just have a week. And one big problem in general with ACA material flow analysis is data is missing. So
Mhm.
maybe also I think a call for the future use to do in the facade world is create more data that people can use and then also understand, okay, how much is recyclable or how much is percentage wise possible to circle back to an input flow. Maybe this is one part as the future, yeah, food for
Yeah,
thought
oh my gosh,
kind of thingy.
that's so true because I like looked at material data sheets, I looked at a number of things, and nothing is clearly telling me
Yes.
this is the percentage of various things. And maybe that's what you guys mean by maybe that is the material passport that was referenced in an earlier. Okay.
Yeah. Got into
Yeah,
that
that would have been
option.
really
Yeah.
helpful. Like I feel like it's information I should have been able to find in 5 minutes, but
Yes.
20 minutes later, I'm like, well, this is silly.
Yes. And
Yeah.
that's a very big problem because we kind of know a little bit, okay, what could be possible, but it's not written down. And then the problem is if it's not written down or published, how can other people use it? So to come to my second part of my answer, find a good source, like Nathan said, and then work with that. And then kind of try to argue why some flows are waste and why some flows can circle back into a recycling, reuse, redo, not redo, remanufacture. Um, yeah, input flow into the system. And then, of course, you can also leave things open and say, okay, it should be possible to recycle, but it's unsure. I found this source that says, okay, maybe 70% can be recycled, but it's a totally different material. But I'm going to go with that because it's physically possible to recycle it. And I think it should be possible also for my material, but I'm not 100% sure. But that is okay if you are transparent. And I think this is maybe the third big point of material flow SCA, be super duper transparent about what you use, how you use it, and then it's okay. Because then I can understand, okay, where's maybe, like I said in my maybe a bit long monologue before, this is where we need to do more. This is where we need to have more information. This is where more research or maybe just more work needs to be done in the industry. And then we know, okay, maybe this is a path that we need to look into more. And then we start a whole new conversation. And yeah, then I'm coming back to my very big point, have fun with it and find out where we can improve. And I mean, there's a solution. In my opinion, there's a solution for everything. We just need to find it. And before that, we need to find the problem area. Maybe then there's a specific problem area that we overlooked, and then we can go deeper.
Cool. So in summary, it is okay to expand the scope.
Sorry,
And when you say,
No,
and when
it's
you say
good.
expand the scope, do you mean go outside of brick and mortar?
Not specifically.
Stick
Not
to brick and
specifically
mortar.
so. Like, I think stick to brick and mortar is fine, but see what you can find.
Okay.
In terms of, yeah, as you said, you were researching what makes the brick and how does a brick how can it be recycled, things like that. Because you might find, obviously, brick's a bit more clear because it is a facade material.
Mhm.
You won't find it used in too many other applications.
Mhm.
But I guess my application of aluminium was that it was hard to find construction aluminium as a data set. It was easy to find
Uh-huh.
aluminium as a material used everywhere because everywhere we go, there's aluminium used. So that's obviously much easier. But to find a facade specific brick example, aluminium example was tough. But maybe you find what I mean about expanding your scope is that with brick, maybe you find a data set outside of, I think you're in the US, correct?
Yeah.
Yeah, maybe there's something outside of the US. And I think for the assignment purpose, it's fine if you, in my opinion, to find a data set that's not specific because this isn't a professional setting where you need the exact answer. We just want to make
Mhm.
sure that people are able to get a data set and analyze what's happening in that data. So if you're having trouble finding the data for your project, I think it's okay to expand outside of the specific
It,
scope.
it was only 20 minutes. I can look harder. I actually I'm curious. So EPDs are obviously becoming very common. Has there been any push in the circularity world of expanding EPDs to include like material composition in it? Um, or are material passports kind of this additional document that kind of supports circularity? Or are we trying to like merge the two worlds of LCA and EPD further? Or LCA and MFA further?
At this point, I would have loved to have Magda here because this is her specialty and where she's researching on, and this is also what her project in IGEA is part of, to really understand how can we merge those two worlds a bit better together to really get an answer to sustainability, to
Mhm.
rate sustainability. So I think this is probably highly interesting for her, this discussion. As far as I know, of course, EPDs are being developed even more. But as far as I know, the time being is that it's about the SA, the impact on the environment, and especially for the primary energy and the CO2 equivalent, the GWP. That this is important at the moment for the EPDs. But I
Yeah.
mean, in the end, people are creating EPDs. If this is a push that needs to be made, then we can also push or be part of this push. So this is maybe the motivational part. In the end,
Yeah.
people make it, and then if it's necessary and we need it, then yeah, then it should be made, in my opinion.
And then I have one other question. Um, Magda's MFA that she did for she had those three that she put up and she said she used
The
global warming.
insulation. Mhm.
Yeah, insulation, yeah, thank you. And she said she used global warming instead of mass as a way to analyze like the flow of the production of CO2.
Mhm.
I was curious if she included the kg carbon dioxide equivalent from the processes or just the materials. Because typically in an LCA we would include um the carbon dioxide emitted from the processes, but I'm wondering if that would apply to a material flow diagram.
To be completely honest, I don't have an answer right now. I'm writing it down, and then I can leave you a comment. Um, yeah, I will ask her, to be honest.
Okay.
I'm not 100% sure at the moment.
I think that's something that would normally be specified in the supporting documentation, correct?
Yes.
As
And I'm not sure
in
if it's
this,
finished already, but I mean,
yeah,
contact her. Maybe I can just ask and she can tell me that. I
But
would
if
maybe
I,
go that
yeah,
way.
but if I understand the question correctly, it's more relating to whether, which part of the material, sorry, what is contributing to the carbon dioxide? Is it the transport from here to there and everything included in terms of that analysis, or certain different boundaries? Is that the question?
Yeah, boundaries
Yeah.
is basically the question. I think given that one of her indicators was like local materials, I feel like yes, transport would be included.
Yeah.
I'm just not curious of like I don't actually know what goes into making maybe the PET shredded or something. The emissions from that process, is that included as well? Um, if we're talking global warming potential, rather than mass in, mass out, in which the processes are not counted, if that makes sense, Nathan.
Yeah, no, that does make sense. Just purely the boundaries. I think I don't know the answer to the question. My guess would be that it's more just about this transparency in your documentation in saying
Yeah.
what I have considered in your report, what I have considered.
Mhm.
And the same with this material flow analysis. It's sort of saying this is what I consider for this data. This
Yeah.
is what this data considers. And you would do the same in an LCA, correct, Bernadette?
Mhm.
You would have,
And that makes sense too, because like if you really want to shine a light on the materials, maybe you don't want to obscure it with the production emissions or everything else.
yeah,
So
It
I can see
depends.
how
If
that's
it's very important, the production emissions to create the product and you can't do it any other way, then it is important again because maybe then it weighs out something different in the different materials. So to be honest, I would probably ask because I think it is included, but this is just I think. I don't know. And I want to give you a good answer to that question because it is an important question to understand the data and to also understand yeah, the the output of the result of this SEA. Because this is again also the part with the system definition, the boundaries. Depending on how we change the boundaries, our result in the end changes. And this is something that we want to be crystal clear about to every other person because then they understand, okay, what did we analyze, what did we assess, and how can they then, for example, compare their result or their material to our results and then going forward. And this is why EPDs are so nice because they have the same boundaries and it's easier to compare them to each other. Of course, there are also differences or like tiny details where we need to be careful with, but it's easier to compare those materials than to each other. But yeah, I'm going to take the question and ask Magda.
cool. All right, just a few more moments left. I think we just only dedicated this time for generic questions, any questions. So if you still have questions, we are
Happy
open for
to answer.
questions. I think the date for final submissions, Bernadette,
Yes.
is
Let
next
me
week,
open. I need
I
to open
believe.
the email. So we have, yes. So the course will end on June 4th at 2 o'clock. And this is the final deadline. So everything a minute before can be uploaded, but afterwards it's very hard for us to extend the deadline. So if you want to finish the course with with a certificate, you really need to upload everything until this time. Afterwards, it's a bit hard to to give you the certification. Yeah. But we will also write a email again, or
Yeah, on
I
Wednesday we
remember.
will summarize all the important information
Yeah.
on the email that we
Did
send
you
for
guys release
Wednesday.
module 6 like a day earlier? Is that too much to ask for?
We can ask Bayer, but I don't know if that's possible.
Okay, no worries. Just to
Yeah,
get a head start because it's the biggest project, but it's okay.
yeah, correct. Potentially, yeah, we could change the opening
Yeah, we
date.
can change.
Um,
Yeah. We just need to ask Bia from the extension school from the TU Delft if that's possible. But in my opinion, it should be okay. We just need to ask if it's okay from the regulatory part.
yeah.
Yeah.
Unfortunately, there's not as much content to take in Module 6, but mostly just the
Oh,
time on
okay.
the project. I
Yeah,
think
got it.
there's
There,
probably about half
sure.
as much content, 2 videos, 3 videos.
Yeah. So a
Um,
bit food for thought, and then a lot of time for you to concentrate on the final project. And there are also all the things that you did now from module 1 to module 5 is building up to the final assignment. So now in the next week you will, or not next week, this Wednesday, you will have the opportunity to transfer the information that you gathered now in the last few weeks to create your own facade. So nothing super new will come, but you will have it's going to be a bit harder because now you have to have your own ideas and then apply all the methods and assignments that we taught you onto a new facade that maybe until today or yesterday just existed in your head. And this is the tricky part about the next part, to maybe spoil you a little bit, make a little spoiler for next week, not next week, this Wednesday. Yeah.
And do feel free to leave any questions in the edX. There's the area in the
Discussion
discussion
board.
for questions.
Yeah.
With the other assignments, we've just been monitoring, but not being too involved to allow it to be kind of like learners discussion, I guess. But with if you have direct questions, just feel free to ask, and over the next week we'll be able to answer because we understand that everything needs to be in by the 4th.
Yes.
Cool. I think that's
it.
probably everything. Thank you very much for joining, everyone. I hope the course has been enjoyable.
Yeah, it's been great. Thank you.
Yeah. No more last questions before we go? I don't think so. Cool.
Then at least we showed the slide, Nathan.
Yeah.
It was important
I
part.
did add the last slide. We didn't have time. I wanted to show this project, which I
Oh,
found
yeah.
interesting.
And maybe you can say 1 or 2 sentences
Yeah.
to end
No,
the
this was
round.
just a project I saw in Yogyakarta in Indonesia a few years ago that I forgot about. And when I saw Partridge's submission, it reminded me of this, where it's purely just doors and shutters to make the facade. I think it's pretty funny.
Yeah.
I think I'm gonna guess that Bernadette likes it. Bernadette, you seem to like the mixed
Yeah.
colors.
Yeah, I
Yeah,
think there was a comment from someone about the aesthetics of reusing materials. I think Durnell or maybe Matteo or something. Just a generic question about what do we do about the fact that reusing materials might not look nice. For example, brick. And I don't I don't have an answer. I like this, so
Yeah,
that's my answer.
Yeah, I think
Funny.
aesthetics is such a subjective topic, and everything can be beautiful if you form it or present it in the right way. Everything
Yeah.
can be nice and playful. And this, I love it. I love the
It's so
facade.
fun. It's so funny.
Yeah.
It's great.
But well, you just took a picture, but is it openable? Like, are they functional or is it like a fully?
I'm not too sure. I looked at the project a little bit. It's a hostel or a hotel or something. I don't think they're openable, but also obviously it's not waterproof, so behind isn't the rooms. It's kind of like, I think you can see somewhere there's stairs through here. It's like a
Mhm.
kind of like open breezeway stair. You can see the project online anyway.
Okay, yeah.
It's more just a fun thing. I guess it performs some shading. But yeah, interesting to see, I think, directly reusing.
Yeah, and sometimes that's also a good solution. I'm absolutely for it.
It's
Maybe not
great.
for every building, but then again, it's the term function comes into my mind. Totally depends on the function.
Oh, exactly. It's great. All right, we'll leave it there.
Then have a nice week. I'm very much looking forward to your final assessments. And yeah, have fun.
Cool. Thank you, everyone.
Bye.
Bye bye.